You are welcome to the Scholar Online class.
The Scholar School will establish our footprints on the sand of time. You can't afford to miss any bits of this class. Experience the difference.
Now, moving to the second aspect of the content, differentiation from first principle. So in differentiating from first principle, that is the origin of differentiation itself. The origin of differentiation of itself. You know, if you are plotting graph, mathematics graph in particular, you are always plotting what? Y against X. This is my Y, this is my X axis. No matter the nature of the graph, either it is a curve or a straight line. So let's say we are plotting a graph in this nature. Have with me. This is our slope here. We take this portion, then we take this portion here, and we take this portion here. Let's assume that the first portion, this is my y1, and let's say this is y2. And let's take this one as x1, and this as x2. Then covering this portion here. So from what we have here, definitely this my line or my graph is covering a portion here or a particular area. Let's say this is A, B, C, D, and E. So you look at the triangle here, ABC is called our slope in our normal graph or our gradient. So if you look at the portion covered by ABC, this portion D to C is what? Y1 and Y2. So the distance covered from here to here is what we call our change in Y. That is Y2 minus Y1. And we are presenting it as what? Change in Y, which we call delta Y. So in other contexts, we can use this delta Y, which I prefer to use, or you use this. Then the same thing for X. This portion covered here is what? X2 minus X1, which we call what? Change in X, or delta X. So this change in Y and change in X take us to the concept of differentiation from first principle. Just like this portion here, the hypotenuse here, just like in your triangle, the square of the hypotenuse is equal to what? The sum of the squares of the other two sides. So if you are looking for this portion here, the distance covered here, we are going to use the concept of distance between what? Between two lines or 2 points, which is going to be what? D squared minus D squared. So applying this now from our concept of gradient or slope of a line, we define it as what? Change in Y over change in X, or little increment in Y over little increment in X. Please be careful. Change in Y and change in X is different from dy over dx. We'll get there. So the little increment here is what we mean as our change in Y over change in X, which is defined as, that is my M, which we call slope, which is defined as y2 minus y1 over x2 minus y1, which translates to change in Y over change in Y, or delta Y over delta X. So from the concept of gradient here, then this will take us to what we call differentiation from first principle. But this is just the basis of our differentiation, which is what our gradient. Now I'm using y2 and y1. Sometimes we can use function f of x. So if you use for choice, it's also what? It's also the same thing. So now let's take example on differentiation from first principle. So example, differentiate the following functions from first principle. From first principle. Number 1, y is equals to x. Let's start with that. Number 2, y is equals to, f of x is equals to x squared. And number 3, let's say f of x. Remember I say f of x even as what? Is equals to x squared plus 3x minus 2. I think these 3 we cover. So I've taken monomial, and I've taken square, and I've taken what? Polynomial or trinomials. Now, solution. Now, in differentiating from first principle, it's what? It is stepwise. So we are going to look at the steps together. The first one, y is equals to x. Step 1, add increments in x. In y, add increments to both sides of the equation. Add what? Increments to both sides of the equation. And when I say increment there, you see I just defined it earlier. The increment here is what? Delta y or delta x. So since to the left hand side I have delta y, I have y, so I'll add delta y to the left hand side, and to the right hand side I'll add what? Delta x. So that means I have y plus change in y is equals to x plus change in x. That's step 1. Step 2, subtract the initial equation. My initial equation is this. Subtract the initial equation from the new equation. And this is my new equation. That is, to the left hand side, I'll be having y plus delta y minus y is equals to x plus delta x minus x. So that translates to this minus will give me change in y. This minus will give me what? Change in x. I hope you are with me. Then step 3. Divide all through by delta x. So what that means is that I have delta y over delta x is equals to delta x over delta x, which means I have delta y over delta x is equals to 1. Then the final step, which is step 4. Our step 4 is to what now? As limit of delta y over delta x. Step 4. As limit of delta y over delta x tends to 0. When it tends to 0, automatically it transforms to what? dy over dx. Anytime the limit of this tends to 0, it automatically turns toward dy over dx. So as limit of this tends to 0, then that is I have what? dy over dx is equals to 1, which is the answer of what you have to differentiate. So that answers the first part. I hope it's clear. Now let's take the second part, the second example here. Now for the second example here, we are having square. Now this first one looks so simple because the power of x is just 1. But if the power of x is more than 1, the more the power, the more complicated it will become. So let's look at the second one. Now this I'm going to take a new dimension, or should I use the same method? So let's see, f of x is equals to x squared. Now to the left hand side, just like I did step 1, add what? Increment. Add increment to both sides of the equation. So that means that I have f into x plus delta x is equals to x plus delta x. all squared. Now look at under this context now. I'm using what? F into x plus delta x, because what I have is f of x. And I say it's similar as y. So is that you use your y, or you can also maintain this. It's still the same thing. So that's step one. So still under step one, I have to expand this expression here on the right hand side. So I have f into x plus delta x is equals to x plus delta x. You're writing this twice into x plus delta x. By expansion, x times x, x squared. X times delta x, x delta x. Delta x times x, also x delta x. And delta x times delta x will give us what? Delta x all squared. Please note, x times delta x is not equals to delta x times x. This is wrong. The x should be placed, because this is one entity. This is another entity. So you cannot place it in the front, because if you place it in the front, the assumption is this is going to be delta x squared. And this is not correct. Another thing you need to know is that delta x times delta x is not equals to delta x squared, like this. No. So you have two entities, so you have to put them in bracket as delta x all squared. And that's why you see me put it this way. So you don't write it together. So this is the expansion of this. So now from what you have here, I have f of x, f into x plus delta x is equals to x squared. This and this you can add as 2x delta x plus delta x all squared. That's step one. So step two, just like I have earlier in the first one, is to do what? Subtract. Subtract the initial equation from the new equation. Our initial equation is what? Where I started from, which is this. And this is my new equation. So that means to the left hand side, I have f into x plus delta x minus f of x is equals to x squared plus 2x delta x plus delta x all squared minus what? X squared. So from the look of things, this one will cancel this one. So I'll be having f into x plus delta x is equal minus f of x is equals to what? 2x delta x plus delta x all squared. So these are cancelled out. So step 3. Just like we have it earlier, what do we do now? Divide. Divide all through by what? Delta x. So what that means is that anywhere I see, okay, what that means is that what? What that means is that what? I'm going to divide with my down. Okay. So what that means is that I'm going to have now to the left hand side f into x plus delta x minus f of x all over delta x to the left is equals to 2x delta x over delta s plus delta x squared over delta x. And this will transform to, this cancel this, I have 2x plus delta x. One of these will cancel. Final step, as f into x plus delta s minus f of x over x. Limit of this now tends to what? 0. So I say all this one here now, as they tend to 0, they transform to what? dy over ds. So meaning that anywhere I see delta x, it will turn to what? 0. So as limit of this tends to 0, my delta s is also what? Tends to what? 0. My delta x will also tend to 0. So therefore our answer, the y value is going to be what? Only what? 2x. The y value is equals to 2x. Then quickly to the third one, to the third example. We have f of x is equals to x squared plus 3x minus 2. So following the same trend, This is polynomial now. The first two are monomials. So we are now dealing with polynomials. So I have f of x is equals to x squared plus 3x minus 2. Remember, I say f of x is same as y. So I think I'll prefer to change this one to y. So that you can see I've applied another method. So the choice is yours to pick the one that is suitable for you. So I would prefer to use my f of x here as y. So that means I can write it as y is equals to x squared plus 3x minus 2. Still the same procedure. Step 1 is what? Add increment to both what? Sides of the equation. So that means I have y plus delta y is equals to x plus delta x squared plus 3 into x plus delta x, then minus 2 because it's not having x. So the next thing is to expand this. Y plus delta y is equals, remember we have expanded this before. So this will give me x squared plus 2x delta x plus delta x all squared. The expansion of this is just what we just finished in the second example. Then this one plus, open the bracket, 3 times x will give us 3x, 3 times this will give us 3 delta x minus 2. I move to step 2. So step 2, what are we to do in step 2? Subtract equation 1. Subtract the initial equation, our initial equation, from the new equation. So what that translates is that y plus delta y, my new equation is what? Y here, minus y is equals to, I can group this one, x squared plus 3x minus 2, right? Group them together. Then the one with delta s plus 2x delta x plus delta x squared plus 3 delta x. Then I'm subtracting minus what? The initial equation is what? x squared plus 3x minus 2. I hope that is taken. So from what we have here, you see that something we cancel out. So from the left-hand side of our equation, y minus y gone, meaning what? Delta y is equal to, look at this and look at this expression. You see that what? They are the same. So this minus this, we cancel out, remaining what? 2x delta s plus delta x squared plus 3 delta s. And step 3, divide all through by delta y, by delta x rather. So that means I have delta y over delta x is equals to 2x delta x over delta x plus delta x all squared. Delta x all squared over delta x plus 3 delta x over delta x. So this will give me delta y over delta x is equals to, this cancel this as 2x, then this cancel that as plus delta x, this cancel that as what? Plus 3. So therefore, as limit delta y over delta x tends to what? 0. This will transform to what? Dy over dx. So as this tends to 0, our delta x will also what? Tend to what? 0. So anywhere you see delta x, it becomes 0. So what will remain is what? Dy over dx is equals to what? 2x plus 3. And that ends the differentiation from first principle. Let's now go to differentiation from what? Formula. So this one is the basis of our differentiation from formula. So differentiation from formula. Though we also have the fractional part of this, but later we'll look at that. Differentiation. When I say differentiation from formula, it means the general formula in which, if you are not to differentiate from first principle, it will just give you what? A direct answer. And I'm going to use the example which I use for differentiation from first principle. Differentiation from Differentiation from what? Formula. That is the general differentiation formula. So what is the general formulation from? Just like I stated earlier. So assuming if y is equals to x raised power n, then what the law says that is what? Dy over dx is equals to what? Drop the power, that's n, times x, then subtract 1 from the power again. This is what we call the general differentiation formula. If y is equals to x raised power n, then dy over dx is equals to what? N times x raised power what? N minus 1. If you recall the example that we did in the differentiation for first principle, the first one I said y is equals to x, the second one f of x is equals to x squared, and the third one f of x is equals to 2x squared minus 3x plus 5. So I'm going to use this example to explain this. Now, let's say we have to differentiate this, and let's see, compare if we are going to get the same answer. Now, let's say the first one, example. I'm to differentiate y is equals to x. So we assume that this x is carrying power of 1. So following this rule here, my n here is 1. It means that dy over dx is equals to what? Drop the power 1 times x raised power 1 minus 1. And that translates to what? 1 times x raised power 0. And we all know that n raised to power 0 is what? 1. So that means our answer will be what? 1 times 1, which is equals to 1. Please, you can compare with that of differentiation from first principle and see if the answer correlates. That's the first one. Now, looking at the second one, the example 2, we have to differentiate. Y is equals to x raised power 2, or f of x, the same thing. F of x is equals to x raised power 2. Now, I'm not going to change this. You should note that if I say f of x, another way of putting it is same as what? Y. So if I also say dy over ds, another way of putting it is what? F prime of x. So I may not write dy over ds, but if you need to see f prime of x, it's also dy over ds. So that's what I'm doing. So I'm not going to change it. So my dy over ds is what? F prime of x, which is same as dy over ds. According to the law, drop the power 2 times x raised power 2 minus 1. And that translates to what? 2x raised power what? 1, which is same as what? 2x. You can cross check. Then for the last one, which is the third one here, you have to differentiate. Y is equals to number 3. Y is equals to 2x squared minus 3x plus 5. Following the same principle, dy over ds. We are going to do this separate. This is 2, this is 1. So the first one, drop the power 2 times 2. X is power what? 2 minus 1. The second one minus 3 times 1, or let's say 1 times 3. I drop the power 1 times 3. X is power what? 1 minus 1 plus 0. Please note, anytime you differentiate constant, y is equals to 4. Anytime you differentiate constant, dy over ds will give us 0. Anytime you differentiate constant, it is always what? 0. So from what you have here, this is going to give me dy over ds is equals to 4x raised power 1 minus 3x raised power what? 0. And that translates to what? 4x minus 3, which is the answer. So this is differentiation using what? Formula. And this is general differentiation formula. So you can apply this to any type of differentiation. Now moving further, which is differentiation of monomial, binomial, and polynomial. So that's what I've just done here. This is monomial, while this is what? Polynomial. So I can have one example more to buttress the polynomials. So assuming using the formula, so differentiation of polynomials. polynomials. Poly means what? More than 2 or 3 and above. So assume we have to differentiate the following. The first one, y is equals to 3x raised to power 4 minus 4x raised to power 3 plus 6x minus 9. The second one, y is equals to x raised to power 3 over 2 minus 1 over square root of x plus 7 over x. Then number 3, y is equals to square root of x minus 1 over square root of x plus 7. Let's look at these three. All these three fall under polynomials. So solution. So for the first one, we have y is equals to 3x raised to power 4 minus 4x raised to power 3 plus 6x minus 9. So we are applying the general differentiation formula, which says that if y is equals to x raised to power n, then our y prime, or the y over ds, is going to be what? N x raised to power n minus 1. So please always remember that formula. So applying that to this, we have dy over ds or y prime or f prime of x. Anywhere you see this, we are still saying the same thing. So I can decide to use y prime. I can decide to use what? F prime of x. I'm still saying the same thing. So this one is going to give me what? Drop the power 4 times 3. Then s is power what? 4 minus 1. Minus drop the power 3 times 4. S is power 3 minus 1. Plus, we assume this is carrying 1. 1 times 6. S is power 1 minus 1. Then minus 0, because this is constant. So this will give me 3 times 4, 12 s is power 3. 3 times 4, 12 s is power 2. Plus 1 times 6, 6s is power 0. And finally, this will give me 12x is power 3 minus 12s is power 2 plus 6 times 1. So therefore, dy over ds is equals to 12s is power 3 minus 12s squared plus 6. That's the answer. Now, moving to the second question. Moving to the second question, I have y is equals to x raised to power 3 over 2 minus 1 over square root of x plus 7 over x. So this will give me dy over ds is equals to, now before we do this, before we get dy over this, anytime you have fraction that is denominator and you have x at the denominator, you must bring it up. You must bring it up to the what? To the numerator level. So it means for the one with fraction, I'm going to bring it up. So this means as y is equals to x raised to power 3 over 2 minus 1 over square root of x means x raised to power half plus 7 over x raised to power 1. So this will now give me y is equals to x raised to power 3 over 2 minus law of indices. When you take this up, it becomes minus. That's 1 x raised to power minus 1 over 2. Are you with me? The same thing with this. Law of indices. When you take this up, it becomes what? Minus 1. 7x raised to power minus 1. So you can see that no fraction again at the denominator. So that's the first thing. All the x must what? Go up. Then you can now apply the rules now. So therefore, dy over ds will give us, apply the rule, drop the power 3, x raised to power 3 minus 1 over 2, minus the same rule, drop the power, minus 1 over 2, open bracket, or let's do it this way, minus 1 times minus 1 over 2, x raised to power minus 1 over 2 minus 1. The law says what? Drop the power, then we use it to multiply this, then you subtract 1 at the same time. Then the last one, plus 7 times minus 1, x raised to power minus 1 minus 1. So this translates to what? 3x raised to power 2 over 2. Minus times minus plus 1 times 1, 1 over 2. x raised power minus 1 over 2 minus 1 give us minus 3 over 2. Then plus times minus, minus 7 times 1, 7. X raised power what? Minus 1 give us minus 2. So finally, I have 3x raised power 2 over 2 plus 1 over 2x raised power 3 over 2. I'll also apply the law of indices. You must take this back. Because of the negative sign, it must go back. So when it's going back, it turns to positive. The same thing with this. Minus 7 over what? X raised power 2. Is that how I leave it like this, or I turn it back to what? The square root sign. But let's leave it this way. Then the last example there, which is what? Square root of x. So it's the same thing with what I just finished doing. Square root of x minus 1 over x, square root of x plus 7. So the first thing is to change that square root sign to ordinary value. So this is going to be x raised power 1 over 2. Anytime you have square root, it means 1 over 2. Y cube root means 1 over 3. Then fourth root means 1 over 4, provided the number is inside, not outside the square root sign. So this will be minus 1 over x raised power half plus 7. Then the next thing to achieve is to take this up, just like I did in the last example there. So this means y is equal to x raised power half minus x raised power minus 1 over 2, then plus 7. So we have dy over dx. That gives me, you drop the power 1 over 2, x is power what? 1 over 2 minus 1, then minus 1 times minus 1 over 2, x is power what? Minus 1 over 2 minus 1 plus 0 when you differentiate constants. And this will transform. So dy over dx is equals to what? 1 over 2, x is power, my half minus 1 will give us minus half. Then minus times minus plus 1 over 2. Minus 1 over 2 minus 1 gives us minus 3 over 2. So finally, dy over dx is equals to, because this is having negative, you take it down, 1 over 2x raised power half plus the same thing with this, 1 over 2x raised power what? 3 over 2. So we can leave it this way. And that is what? That answer. So we are done with this. We are done with this. Now, differentiation from formula. I will just take some of the formula, then we look at 1 or 2 applications and can look at the last aspect here. So when you are differentiating from formulas, the formula that we have here, we have what we call the product rule, the quotient rule, and the chain rules. These are the three we'll be looking at. So starting with the first one, differentiation from formula. Differentiation from formulae. So the first formula is what we call product rule. And from their knowledge, when you say product means what? Multiplication or times. So if y is equals to u times v, u of x times v of x, if y is equals to this, then dy over dx. The rule says that dy over dx is what? You take u, you differentiate the second one, dv over dx, plus take the second one, which is v, you differentiate the first one, du over dx. That's the law. If y is equals to u times v, the law says what? Take the first letter, differentiate the second one, then take the second one, differentiate the first one. So let's look at the example. Differentiate. Y is equals to 3x squared minus 5 into x squared plus 2x minus 3. Minus 3. So, as you have this now, somebody may decide to expand, but expanding is a waste of time, so you just apply the formula. We have two entities here. This is one, this is another entity. So when you have something like this, we apply product rule. So, okay, differentiation from formula. So under this, we'll be looking at three aspects. We have product rule, quotient rule, and chain rules. So starting with the first one, product rule. When you talk about product, means what? Multiplication. For example, if y is equals to u of x times u of x, then according to rule, dy over dx is equals to u. You take u, you differentiate v with respect to x, plus you take v, you differentiate u with respect to x. Example, differentiate y is equals to, open bracket, 3x squared minus 5 bracket close, then open under bracket, x squared plus 2x minus 3 bracket close. To solve this, from what we have here, the first one will be our u. So we have 3x squared minus 5 as our u, then bracket x squared plus 2x minus 3 as our v. So following the rule, then I have, therefore, dy over dx is equals to, take u, that's 3x squared minus 5 in brackets, then you differentiate what? You differentiate the second one, d into x squared plus 2x minus 3 all over ds, plus take v now, x squared plus 2s minus 3, differentiate u, d into 3s squared minus 5 over ds. So going by this, and I have dy over ds is equals to 3x squared minus 5. When you differentiate x squared to give us what? 2x. When you differentiate 2x to give us what? 2. Then plus, take the second one, x squared plus 2x minus 3. When you differentiate 3x squared, that will give us what? 6x. Then when you differentiate constant, that will give us 0. So finally, this will give me 2x plus 2 into 3x squared minus 5 plus x squared plus 2x minus 3, or 6x into x squared plus 2x minus 3. So if you like, we can open the bracket by expansion. 2x times this will give us 6x raised to the power 3. 2x times 5 minus 10x. Then 2 times 3x squared plus 6x squared, and 2 times this will give us minus 10. Plus 6x times x squared will give us 6x raised to the power 3. 6x times this will give us 12x raised to the power 2 minus 6x times 3 minus 18x. So you collect like terms. So finally I have 6x cubed plus another 6x cubed, then minus plus 6x squared in terms of the power, then plus 12x squared, then we go to what? Minus 10x, any other x, minus 18x, and finally you have minus 10. So collecting like terms, so we have 6x squared, 6x cubed is 6x cubed, bring it together, then 6x squared, 12x squared, bring them together, minus 10x, minus 18x, bring them together, then minus 10. So finally, 6 plus 6 will give us 12x raised to the power 3, plus 6 plus 12 will give us 18x raised to the power 2, minus 10 minus 18 will give us minus 28x, and minus 10. And that's the answer for that. So let's look at the second rule, which is quotient rule. And that quotient rule has to do with what? Division of functions. So number 2, quotient rule. So when you talk about quotient rule, we're talking about what? Division. So if, assuming y is equals to u of x over v of x, then according to the law, then dy over dx. Here you are starting with the denominator, which is what? Take your v, then you differentiate your u with respect to what? X. Minus, now take u now. U differentiate what? V with respect to x. Then divided by v squared. This is the formula for quotient rule. So here you are starting with the denominator, but for product rule, anyone can come first. But for quotient rule, the v must always come before the u. That's the denominator first. So again, take the denominator, differentiate the numerator, minus take the numerator, differentiate the denominator over the square of the denominator. So let's look at example. Differentiate. Differentiate y is equals to x squared plus 1 over x squared minus 1. So, solution. We have our y is equals to x squared plus 1 as our u divided by x squared minus 1 as our v. So following the rule says that what we start with the denominator. So then dy over dx is equals to take your v, that's x squared minus 1, differentiate what? Your u, x squared plus 1 over dx, minus take our v now, let's take our u now, x squared plus 1, then differentiate v, the denominator, x squared minus 1 over dx. Everything over what? X squared minus 1 all squared. Mind you don't have any business with the denominator. So you don't expand it, just leave it till the end of the function. So we have dy over dx is equals to, okay. Okay, so you don't have any business with the denominator, just leave it the way it is until the end of the function. So therefore we have dy over dx is equals to x squared minus 1. When you differentiate x squared plus 1, differentiate x squared, that will give us what? 2x. When you differentiate 1, that is what? 0. Minus x squared plus 1. You differentiate this, the same thing, that what? 2x. When you differentiate 1, that's 0. Divided by what? X squared minus 1 all squared. So therefore, dy over dx will give me, you can bring the 2x forward, 2x into x squared minus 1, then minus 2x into x squared plus 1. So when you expand, divided by x squared minus 1 all squared. So let's open the bracket. 2x times 2 will give us 2x raised to power 3. 2x times 2 will give us minus 2x. Minus 2x times this will give us minus 2x raised to power 3. Minus 2x times 1 will give us minus 2x divided by x squared minus 1 all squared. So finally, therefore our dy over dx will give us 2x cubed minus 2x cubed, cancel out. Minus 2x minus 2 will give us what? Minus 4x. Divided by what? X squared minus 1 raised to power 2. And that's the answer. Now going to the third formula, which we call the chain rule or composite function or function of a function. So any of the three names can go. So when we talk about that, it means you have what? You have double functions. You have double function. And in that regard, let's say you have y is equals to u and v, and you are differentiating. Now you are differentiating one function with respect to another. Let's say y is equals to u, and our u is a function of v. Let's say y is a function of u, and u is a function of what? V. Then we are now to find what? Y as a function of what? X. So we have, that's what we call it chain rules. You can look at it as a form of chain. Y is a function of u is a function of v, and y is a function of, we have to find y is a function of x. So under this context, we have to differentiate this. Then it means the first one, you are differentiating y with respect to u, you are differentiating u with respect to v, and we are differentiating y with respect to x. So based on these three analogy here, for the first time I have what? Dy over du. For the second one, I have what? Du over dv. And for the third one, I have what? Dy over dx. So if we decide to bring these three together, then, or let's say y is a function of x, u is a function of x. If we decide to bring these three together so that we can produce something of this nature, then it means that therefore my dy over dx, which is the last one, is equal to what? Dy over du times du over dx. That's what I'm marrying the three together, starting with dy over dx. Now, if you look at what we have on the right-hand side, this cancel this, remaining what? Dy over dx. So the rule is that what? Whenever you have this, when you cancel it, it must always produce the expression on the left-hand side, which is what? Dy over dx. So this is what we call our what? Chain rule or function of function or composite function. So this is what we call our chain rule or composite function or function of function. Function of function. So any of the names can do. So let's take example. Example. Differentiate. Differentiate. Y is equals to 3x squared minus 5x raised to power 7. Now you can see what you have here now. This is what you cannot say you want to write this expression 7 times and now expand. That is waste of time. And if you follow that trend, you may end up making mistakes. So that's why we have this chain rule. So what do you do here? You have to use your chain rule by substitution method. So what you do is what you say, let solution. Solution. So we said if y is equals to, or given, we are given y is equals to 3x squared minus 5x raised to power 7. Here it means we are carrying out two functions simultaneously. So the first thing we say, let u to represent whatever you have inside the brackets. That is, u is equal to what? 3x squared minus 5x. If u is there, then it means that my y will now become what? U raised to power 7. Let's go over it again. This is what we have here. So whatever you have in the bracket, let u to be equal to that thing. It means that what I have in this bracket is now u now. No more this. Then my y will now be what? U raised to power 7. So we are differentiating u with respect to what? X for the first one. And the second one, you are differentiating y with respect to what? U. So in the front, here you are having what? Du over dx. Then here, for the second one, you're having what? Dy over du. So according to the rule, when you differentiate this, drop the power, that's what? 6x. Minus, when you differentiate 5, that will give us what? 5. Then for the second one, when you differentiate this, drop the power, that is 7u raised to power what? 6 by subtracting 1 from the power. So multiplying these two results together, that's your answer. So therefore, my dy over dx is equals to du over ds times dy over du. So if you look at it, this cancel out, producing what? What you have the expression on the left hand side. So what you just multiply these your two answers together. So therefore we have this is going to be what? 6x minus 5 times what? 7u raised to power 6. So we can bring the 7 forward. That is 7 into 6x minus 5 into what's my u? You go back to our u. What's our u? That's what? 3x squared minus 5. That's 3x squared minus 5x raised to power 6. And that is the answer. So this is what we call our composite function or function of function. Now for the last aspect, which is what? The application of differentiation. So we'll just look at one or two applications here. And the first one is, let's say, trig functions. Trigonometric functions. So I'm taking the basic one, differentiation of trigonometric function. The first one, if y is equals to sine x, then dy over ds will give us cos x. The second one, if y is equals to cos x, then dy over ds will give us what? Minus sine x. And the third one, if y is equals to tan x, then dy over ds will give us sec squared x. These are the three fundamentals that you need under these three functions. So how do we apply this? Now, let's look at this function here. Remember, we said that our gradient or slope, which is defined as m, is equals to change in y over change in x, which I can also put as dy over dx, which is what? y2 minus y1 over x2 minus x1. This is one of the applications aside these three. So, but before I go to this other one, let's quickly take an example of this. Example. Differentiate. Number 1, y is equals to cos squared 6x. Then number 2, y is equals to sine 5x squared. So let's look at these two. Let's look at these two examples. This is also under function of function. So solution. Starting the first one, our y is equals to cos squared 6x. This can also be written as y is equals to what? Y is equals to cos 6x. Everything squared. Everything squared. That is the interpretation of what we have here. So here you are differentiating. This is also function of function. Now here I'm having three functions: the square, the 6x, and the cosine. Three functions in one. So this is how we are going to do it. Just like I explained before, this is going to be in form of change. So the first thing you do is that what? Let u to be equal to, start with the one you have inside the bracket. Let u to be equal to what? 6x. And my, what's it called now? Let u is equal to 6x, then I have v is equal to what? Cos u. So therefore, my y will be equal to what? U squared, v squared. Let's go over it again. Start with what you have inside the bracket. Let u to be equal to 6x, right? Then, and v, yes, and v to be equal to what? Cos u, which is cos 6x. Then finally, y is equal to what? V squared. So this is this chain form. So you see the differentiation and see that you are going to arrive at the same answer. So here you are differentiating u with respect to x, v with respect to u, and y with respect to what? V. So the first one we have the u over the x. When you differentiate 6x, it gives us what? Ordinary 6. The second one we have what? dv over du. When you differentiate cos, it will give us what? Minus sine u. And the third one we have dy over dv. When you differentiate this, give us what? 2v. That's all. So therefore, my dy over ds, following the chain is what? The multiplication of these three. That means I have what? Du over dx times what? dv over du times what? dy over dv. Let's see. This cancel this, this cancel this. What do we have left? dy over ds, which must always produce what we have on the left hand side. So that means our expression is what? In order. So right now I have du over ds times dv over du times dy over dv. So let's substitute. Just bring down your answers. That's 6 times minus sine u times 2v. And that'll give me what? Minus 6 times 2. So let's bring this together. 2 times 6 is what? 12v, then sine u. So I'll need to replace my v and my u. So that means my dy over this was minus 12. What's our v? Our v is what? Cos u. Cos u sine u. Which invariably, it means my dy over dx. It means therefore, my dy over dx is equals to, I said it was what? Minus 12 cos u sine u. That's minus 12 cos, what's our u? That is what? 6x. Cos 6x sine 6x. I hope that is clear. Then to the second one, so that is then number 2. Y is equals to sine 5x squared. Now this one is just two functions as compared to this, which is we have three functions here. So the same procedure, let u to be equals to the 5x squared. 5x squared, then my y is equal to what? Sine u. So we now have du over ds. For this, and the second one we have what? Dy over what? Du. So this one, when you differentiate, this give us what? 10x. And when you differentiate, this give us what? Cos u. So therefore, dy over ds will give us what? Du over ds times dy over du, which means we have 10x times cos u, and that gives us 10x cos, what's our u? That's 5x squared, and that is the answer.